We'll continue to see interesting things about C's expression language throughout the course, but for now I want to highlight one important feature of various constructs of the language, which is the concept of strictness. So a strict construct in a language evaluates all of the subparts before it runs. So can you think of anything that is strict in C? You can pause the video for a second and think about it. So what does it mean to be strict? It means that before I can execute this thing, I must evaluate all of, for example, if it's an operator, all of its operands. So what's a strict operator in C? The most common examples are the arithmetic ones. But there's also the comparison operators, the bitwise operators, and function calls significantly are strict in C. So before a C function can be invoked, we must first evaluate all of the arguments to get result or to get values so that we can then copy the values into the function for it to execute. So these are all strict constructs. So what about non-strict ones? Can you think of things that are not strict in C? The one that usually comes to mind first is the double ampersand operator. Double ampersand is not strict. So what does it mean to say E1 and E2? Well, in order to evaluate this expression, first we evaluate E1. Then, depending upon the value of E1, we do different things. If E1 is true, then we must go ahead and evaluate E2. But if E1 is false, there's no reason to evaluate E2. The expression immediately returns false. True and false in C are encoded in the integers. So any non-zero integer is true, and 0 is the unique false value. So this is quite common code in C for safe pointer dereferencing. So pointers normally are 0 when they're not valid. That's considered the void value. And so what this expression says is if P is 0, that's false, then simply the whole value of this expression will be 0. Otherwise, if P is not 0, then I must invoke this method call, and actually the result of the entire operation then is actually simply the result of the method call. So this is very idiomatic in C. We can do the same thing with OR, and in this case we turn things around when we're messing with pointers. So the value of this expression is determined as follows. First we evaluate E1. If E1 is true, then the expression is true. There's no reason to evaluate E2. If E1 is false, then the result of the expression is the value of E2. So in this case, if we're doing this kind of null testing, we would want our first condition to be true in the case that P is null, so that we don't then evaluate this. The Boolean operators in C, the equality operator, I believe is going to return 0 or 1 on most implementations, but it's always going to return a non-zero value. There are other things in C that are non-strict, including the ternary operator, which is the conditional, if E1, then E2, else E3, and macro expansion. Note that we can express both and or in terms of the ternary operator. It's a useful exercise to do it. I'll talk about macro expansion in a sec more. But the ternary operator is very useful in C. So this expression, again, will evaluate E1. If E1 is true, then we evaluate E2. Otherwise, we evaluate E3. If you take a program like this, what am I going to do? I'm going to loop 10 times. I'm going to choose X and Y initially to be 0, and Z is a random number. So actually what I'm doing here is flipping a coin randomly, deciding whether or not Z is going to be 111 or 222. Now you might note here I'm using side effecting expressions. So here we have a side effect. We will assign X to 1 and give 111. Or we have the side effect of assigning Y to 2 and then giving 222. So this expression here can tell us whether or not the ternary operator in C is indeed strict or not strict. Because if it is strict, then every time we assign Z, we will be updating both X and Y, because we'll be evaluating both of these expressions. If it's non-strict, we'll only be updating one of them. So we can run it and see what it does. So here it is. Let's run it. And you can see indeed each time I only update either X or Y. I don't update both. We can use the ternary expression in C to express conditionals just like we use if then else. So this is often used for expressing recursive functions such as the factorial. Here you can see the factorial where I have the conditional in the statement language. So if in is a base case, return 1, otherwise return n times the factorial. And here I've simply turned those things around. So the return is on the outside and my conditional is inside the return. So what I'm going to return is the result of this expression. If we're at a base case, return 1, otherwise do a recursive call and then multiply by n. So let's look at the same example code we had a second ago. What I'm going to do though is I'm going to put the use of the conditional inside of a function call. So my function here is going to take 3 parameters, the Boolean value, and then true value and a false value, and it's going to return either the true or the false value based on the Boolean. And now I'm passing in the random coin flip and the result of this expression, which is going to be 111, and the result of this expression, which is going to be 222. But note that in evaluating these expressions, I'm also having side effects. So the side effect here will be to assign both 1 and 2, both X and Y. So if we run it, you can see the result. C also has the concept of a macro. Macros syntactically look very similar to functions when they're used. However, they have a completely different semantics. So here I have a macro conditional. Macros are not evaluated like functions. Instead, they're evaluated by what's called macro expansion. Before the program is compiled, the body of the macro is simply substituted verbatim for the occurrence of the macro call with appropriate substitutions for parameters. So in this case, by putting this in here, it's exactly the same as if I had typed in the ternary operator directly. So in this case, we will conditionally determine by our coin flip whether we're going to return 111 or 222. But in this case, because we have the ternary operator here, we're only going to execute one or the other, not both. And as a result, we only get one of the values, X or Y, set to 0. So macro calls are evaluated in the compiler by textual substitution. And this makes the mix of macro calls and side effecting expressions quite exciting. So if you have a function that uses a parameter multiple times, that will have a very different effect than if I have a macro that uses a parameter multiple times. In the case that I pass a side-affecting expression into the function. How do we expect this to execute? Well, what's going to happen here is initially x is 10. In order to invoke the function f triple, we first must evaluate this expression. This will add 10 and 1 and store the result in x. The entire expression will have the value 11, in addition to updating x. So what do we expect f triple to print out, or to be? It'll be 11 plus 11 plus 11, which is 33. Instead, what happens with im triple? Well, something very different here, because im triple is expanded by the compiler. So what we're going to have is this expression repeated 3 times. So y gets y plus 1 plus y gets y plus 1 plus y gets y plus 1. So the first expression we expect to give us 11, the second 12, and the third 13. That's what I expect. When I ran this on my computer last time, that is indeed what it gave me. So I ended up with 36. Let's see what happens today. Indeed, today I'm getting 36. At least that's what GCC is telling me. Oh, or is it GCC? One thing to know about the Mac is that GCC on the Mac is not actually GCC. It's really an alias for a different compiler called Clang. So if you run Clang, you'll get exactly the same thing you're getting as if you run GCC. So in order to get the real GCC, you have to install it somewhere else, which I've done. So I can run it by calling GCC 9 on my computer. And let's see what happens when I run GCC 9. Well, you'll first of all note that I get a different set of warnings. That's to be expected because warnings aren't really part of the language. It's just something the compiler is doing to help you out. Oh, but this is troubling. Note that on Clang and GCC, I actually get different values. How is that possible? For the answer, stay tuned to the next lecture.